Hey, this is our senior design project presentation. Our team is called Exquizite. So as you know, in a lot of schools and colleges, students are directly linked with a lot of these different testing applications, such as we have Canvas, and a lot of other classes will use different methods. And the quality of these assessments is only as good as the questions created. And so our team hopes to create an importable testing platform that will help both students and teachers. It'll allow educators to create, manage, and grade assessments, while students can easily take said assessments, track their stats, and easily get feedback from the teachers. We'll be using cutting-edge technology such as natural language processing and machine learning to generate very high-quality questions and complete assessments. So our tech stack, we'll be using Node.js, MongoDB, and Express for the backend interface, and we'll be using Flutter for the Android, iOS, and web front end. We'll also be using natural language processing and machine learning APIs to analyze the media and generate the assessments. We'll be using OpenAI's DaVinci API and fine-tuning it for our specific use, Whisper API for the media transcription, and we'll be using Google Cloud optical character recognition API.
So for our software architecture diagrams, we've divided all our main features into separate diagrams and components. The recurring theme for each of our features is that our user will face a Flutter front-end web page. Behind that web page is a Dart class, which will basically store the data and call API requests, communicating back and forth with our internal API. And then our API would store user data or whatever data we need in our MongoDB database. Occasionally, such as in this case, in the user registration module, we will also connect to an external API, such as an email service API, to generate a one-time passcode and authenticate our users. So in this case, the user basically goes through a registration page, the data is transferred to our API, the API confirms if the user could register or not. They're also taken through a verification module, and finally a success page. Now we get to our actual main features, the first of which is our assessment management system. So if a user would like to create a specific assessment, first they need to create a question bank, and they're faced with a question bank creation page where they'd add details for that actual question bank, such as the topic name, the subject, etc. And then that information would be communicated through our question bank Dart class through our API. If it's a success, it's stored in our database, and the user goes on to a question generation page. This is where all the magic happens, and the user basically inputs a text prompt or a file such as a PDF or a video or an audio recording of specific information and sends it off to our API. Now, during this stage, our API communicates to the OpenAI DaVinci API, which is fine-tuned for our use case. It provides all the information the DaVinci API needs, such as the prompt, such as the text prompt, the number of questions, the difficulty, the format, etc. And it gets back the generated questions, which go back to the user on the question generation page. Now, once it gets back to the user, all the user has to do is confirm the questions they need, delete the questions, edit the questions, and once they're satisfied with everything, they go on to the generate assessment page. In the generate assessment page, they basically finalize an assessment to send off to a student or even keep for their own personal use and study purposes, and they just set a name for the assessment. They have options to share a link to the assessment and anything else.
So these are our wireframes for the onboarding, the sign up and the verification. As you can see, these are very standard across different apps, and that's why like users rely on familiarity. So that's our overall design approach for here. Then we have the login and the home. As you can see in the home, you can see the typical profile picture that means that you can access and change the settings of an account. And the login is also a very classic login account. Here are the manage account, reset password, the verification page, and the success. Again, very, very standard across different apps. This is the upload class material. So basically, users will be able to choose a file and then see a preview of the file they're uploading. They can give it a name and press the confirm button to continue. As for the create a question bank, here's where users will be able to put the details in the text fields for the questions banks, and then they'll be able to swipe left and right to approve or disapprove the questions that will provide. Then they can click the continue button and confirm that these are the questions they've selected. This is the final step, the configure assessment, where they'll see different ways of setting different types of data for these assessments. We still are working on it, so it isn't very clear in the design, but the idea here is that it's not just button, but we also have sliders and drop-down menus. Then the users will be able to see a scroll view of the assessment. And in these screens, they'll be able to take the assessment. Again, very user-friendly and pretty standard.
So the progress that we've made so far, we've definitely, up until now with this presentation, we've showed the progress that we made. We completed our project proposal, which helped us stay organized as well as plan out this entire project. We also interviewed an edutech specialist and machine learning engineer that's working in the same domain. So their input was very helpful. We continue to organize our team. We've been using Kanban board to divvy up the tasks so that everything stays organized and everyone knows the tasks that they are assigned, as well as we have weekly team meetings to catch up on progress or ask any questions that need to be answered. We've also made the wireframes that Mariano explained, showing a concept of what it's supposed to look like, as well as the many software architecture diagrams. And then we've also made a proof of concept, which is going to be in the next couple slides I will be showing you, basically the REST API built in with Node.js. it expresses the connectivity to DaVinci API and generate questions from a text prompt. And then we've also set up the environment. So in this first screenshot, it shows the proof of concept in that it's the input prompt field. So we input the field with information on a topic. In this case, it's mitosis. We included like a paragraph or two of information. And then at the bottom here, you can see number of questions. So let's say this is a teacher. They give a whole paragraph on mitosis, and then they input the number of questions that they want on that topic. And then with the second screenshot for our proof of concept, this is what the API spits out to us. It generates a question and then also gives options and even provides the answer. So the API spits out a JSON file that is produced from the API with the prompt and the number of questions. So basically, we feed it an example or a paragraph of information, and it spits out questions that they can test their students on.
Here are our individual responsibilities throughout this project. I will be focusing on the Flutter front end, specifically managing the screen states and data, connecting to our API, and making sure our screen designs are scalable for multiple platforms, such as different phone screens or websites. I'll also be working on the Node.js backend with a specific focus on generating questions, connecting to the DaVinci API, and fine-tuning our model we'll be working on. I'll also try and take on the responsibility of a Scrum Master to facilitate the Scrum process amongst our team.
I'll be focusing on data organization and the pipeline with the MongoDB storage that we were using. I'll also be working on the storage interactions and just anytime data needs population from the backend.
I'll be helping with the Flutter frontend. I have a lot of experience with React Native, so multi-platform frontend, but still have to play around with Flutter to be able to help a lot on this project. For the backend, I'm thinking of contributing with the authentication features. We're considering using Firebase authentication, but that's still not totally decided. And I'll try to apply and make suggestions related to the build process based on my software development experience.
I'll be working on the backend. I have experience with using MongoDB as a cloud database. I'm even taking a class right now that's using MongoDB, so it's helping me refresh. And I'm going to be using Node.js to communicate and connect to MongoDB. And it's going to be, like I said, communicating with MongoDB to manipulate, change the database in any way.
And that's all from us. Thank you for listening.